All right, so for section 5.2, we're going to talk about verifying trig identities. This video is kind of short just because we've already talked about the trig identities in section 5.1. So I just want to go over two example problems that are problems similar to what you're going to run into on the homework. So since we already know the trig identities, now we will just be asked to verify things like, for example, our goal is to verify that the cotangent of x times the tangent of x equals 1. Okay? And so your goal here is to try to multiply these together in some form and make sure that they equal 1 using all of those trig identities that we had in section 5.1. So as an example, if I refer to my list of trig identities, cotangent of x is equal to cosine of x divided by the sine of x. Okay. Then tangent of x is equal to the sine of x divided by the cosine of x. So now I'm just going to substitute these in for my original equation and just see if they equal 1. So cosine of x over sine of x times sine of x over cosine of x equals 1. So cosine divided by cosine is 1. Sine divided by sine is 1. So 1 does equal 1. And so it is verified. Okay. So that is all that you're doing for section 5.2 is just you're given an equation and you just have to input the proper trig identity just to verify that the equation is accurate. So here's another one, and this uses one of those Pythagorean identities. So verify that cosine squared of beta minus sine squared beta is equal to 1 minus 2 sine squared beta. Okay. And so in looking at this, the only thing identity-wise that I had that used cosine squared and sine squared was the Pythagorean identity, which says that cosine squared beta plus sine squared beta is equal to 1. And since I'm trying to get it into a form of 1 minus something sine squared, I'm going to move my cosine squared, my sine squared over. So now cosine squared beta is equal to 1 minus sine squared beta. Okay, so now I'm going to substitute in for cosine squared beta, and what I get is 1 minus sine squared beta minus sine squared beta, and 1, and then combining the sine squared betas, there's 2 of those, 2 sine squared beta, which equals my original. And so therefore I verified it. Okay, so that's all you're going to do. 5.2 is a very short section. It's just using some more of those trig identities to just verify these equations. So if you have any questions, please feel free to email me, and have a great rest of your day.